All right, so if we have what's effectively like the hypotenuse for one of our vectors, and you call those tensions, so we'll call this FT, all right? And that is similar to a triangle that would be like A, B, C, right? Where we have A, B, and C, and that's theta. Now, so this force that's at an angle has a component that is horizontal and a component that is vertical. Okay? Could you measure with the protractor that's at your table? Could you measure this theta right here? Yes. Okay. So could you find FTX, the force of the tension that's in the x direction? You've got spring scales on your string that's giving you the tension. You've got a protractor that has the angle. How would you find the adjacent side? What would you use? Cosine. The cosine of theta is adjacent over hypotenuse. So if I multiply by FT on both sides, I get the force of tension in the x direction is equal to FT cosine theta. Could I do that for the vertical component or the y component? The force of tension in the y direction? It's going to be the sine function. So the sine of theta is equal to the opposite FTY over the hypotenuse FT. So then FTY would be equal to FT sine theta. Now if I take that to a more general case, I could say that the force in the x direction for any kind of force, a weight force, a spring force, whatever force it is that's not in the x direction or the y direction, but it's in both directions, I could find the x component by taking the magnitude of the force times the cosine of the angle measured to the horizontal. Okay? Because that's where we've measured it up here to the horizontal. Again, I could find the y component of whatever force it is, a weight force, a tension force, a spring force, times the sine of the angle that is measured to the horizontal. So those are two general equations for finding your component. And I am going to make a note that this is for when theta is measured to the horizontal. Okay, so that allows you to find the x and y components. Now for a free body diagram that looks like this, where you had your, maybe you have FT1 and FT2, and this was your FG. Can you use this model to find the sum of the forces in the x direction and the sum of the forces in the y direction?